Okay, so to continue our talk about functions and continuing our talk about graphing functions, we're going to talk about piecewise functions. So what piecewise functions are graphs of functions, are multiple different functions that are pieced together into one. So we use piecewise functions when you have a multiple different representations that represent the same scenario. So we'll talk about that a little bit towards the end of our talk about piecewise functions and how we'd use them in scenarios where you might need 3 different functions to represent the same scenario. So the learning targets today, we're going to learn how to graph the piecewise functions. We want to be able to analyze the piecewise functions, so finding the domain, the range, the intercepts, also different values of the function, and also to be able to write the definition of a piecewise function given its graph, which is not something that we will do today in the video, but we will talk about in class the next time I see you. So here's an example of a piecewise function. So as you can see, we have 1 f of x equals 3 different functions. So we have x squared, where x is less than or equal to 0. We have 2 when x is greater than 0 and less than 2. And we have the absolute value of x when x is greater than or equal to 2. So again, this is one function, but it's split into 3 different pieces. So each piece represents a different part of that function. So when we're looking at this function, the first piece is the x squared, the second piece is the 2, and then the third piece is the absolute value of x. So the first thing I want you to be able to do is tell me, what is the domain of this function? If I were to graph this, what x values would this span across? So when we're looking at the domain, we're looking at the possible x values. So that's going to be here. This gives me the restrictions on that function. These are my possible x values for each piece of the function. So for the x squared, that ranges where the domain for just x squared is only when x is less than or equal to 0. So my function will take the shape of an x squared function only when x is less than or equal to 0. Then my function is going to be equal to 2 for all the values of x between 0 and 2. Then my function is going to be equal to the absolute value of x for all the values where x is greater than or equal to 2. So if we put that together, we have x is less than or equal to 0. So that is anything from negative infinity to 0. It can be equal to that, to 0. This one, then I have between 0 and 2, but not equal to 0 or 2. Then I have all the values from 2 to infinity. So as you can see, if I go from negative infinity to 0, then 0 to 2, then 2 to infinity, that means my entire domain, if you put all of those pieces together, the entire domain spans from negative infinity to infinity. Let's actually write that in our correct format. So for a piecewise function, when you're trying to figure out the domain, you just want to piece together the different pieces, and when you put it all together, what does the entire domain span? So in this case, it would be from negative infinity to infinity. Okay, the next thing we want to look at are the intercepts. How do you find x and y intercepts for a piecewise function? For the y-intercepts, we know that in any function, to find a y-intercept, x always needs to be equal to 0? Well, we have 3 different function pieces here. And we need to figure out which one are we going to plug in 0 for x. So look at our 3 different domains: negative infinity to 0, 0 to 2, and 2 to infinity. Which one includes the value for x of 0? So the first one, when x is greater than or equal to 0, that is the only part of the domain that includes 0 in the x values. Okay, in the second one, 0 to 2, x can't be equal to 0 in that one. And in the third one, it's only the x values that are greater than 2, so 0 is not included in that. So the only one where it will work, where x is 0, is that very top function. So if you plug in 0 for x, so we get y is equal to x squared is the function that we're going to use. Plug in 0 for x, so we get y is equal to 0. So our y-intercept is going to be 0, 0. The x-intercept now, we plug in 0 for y. So 0 goes into the f of x, or the y. So in this case, we can have more than one x-intercept. And that makes sense. On a graph can cross the x-axis more than one time in a function. So we're going to plug in 0 for y for each of those 3 different functions. So I have 0 equals x squared, 0 equals 2, and 0 equals the absolute value of x. So in each case, solve for x to get x equals 0 for this one. 0 equals 2. That is not possible. So that's no solution. And we get x equals 0 for this one also. So my one x-intercept is 0, 0. So you can have just one x-intercept. It's possible to have more than one. In this case, there's just one. All right, the next thing we're going to do is we are going to find the following using the piecewise function. So f of -2, f of 1, and f of 4. So this is very similar to finding the x-intercepts. In this case, my -2, f of -2. Remember, when you have a number inside the parentheses like that, that is your input. So that's what tells us what we're going to input in for x. So again, we need to figure out where in my domain do I have an x value of -2. So if you look at the very top function, x squared, the domain is x is anything less than or equal to 0. Well, the x I'm plugging in is -2, so that fits right in the domain. It wouldn't work in my second equation because the x's can only be between 0 and 2. So -2 doesn't fit in there. The bottom function doesn't work because my x's have to be anything greater than or equal to 2, and -2 doesn't fit into that. So my -2, my x value, gets inputted into the top function. So x squared, or -2 squared, which is 4. F of 1. So now my input, my x value, is 1. So figure out which domain that goes into. Can't go into the top one because that has to be anything less than or equal to 0. So we have between 0 and 2. Okay, 1 is between 0 and 2, so it's going to go into my second one. So that function, we just have f of x is equal to 2. So no matter what my input is, my output is always going to be 2. Last one, f of 4 is going to be my x value is going to be 4. So that's going to fit into my very last domain where my x's are anything greater than or equal to 2. Since 4 is greater than or equal to 2, we're going to use our absolute value of x function. So we're taking the absolute value of 4, which is 4. So whenever you're plugging in an x value, you just need to figure out which one of those domains does that x value fit into. All right, lastly, let's graph this and talk about the range. All right, so we're going to just graph each function piece by piece. So my first function is x squared. So that is anything, I can have an x squared function wherever x is less than or equal to 0. So I'm going to start at 0. So that means that x squared function can only be in this part of the graph, from 0 and less. So what I'm going to do is I'm going to start with 0 and plug that into the function. So if I take 0 and plug it into x squared, I get 0. 0 squared is 0. Now, since the domain for this particular function, for the x squared function, since the domain is anything less than or equal to 0, then I'm going to keep going down. So from 0 to -1, that's less than. So if I plug in -1 into x squared, -1 squared is 1. So that point would be -1, 1. Keep going, -2. If I plug in -2 to x squared, I get +4, so -2, +4. And I'm kind of running out of space, so I can just go ahead, and it goes to negative infinity, so I can go ahead and draw an arrow up there, because we know that would just keep going. Can't keep going to the right. I'm not going to draw an arrow here, because in a piecewise function, this can only be from 0 and less. So 0 is my stopping point. Okay, let's graph f of x equals 2. Okay. So that is the function just y equals 2. That's just going to be a straight horizontal line at y is equal to 2. Now, notice this domain is only where x is greater than or less than 2, but not equal to. So I'm still going to start at 0, but I'm going to do an open circle because it can't be equal to 0, only greater than 0. Okay, and then it goes, it's going to be equal to 2 all the way up until 2 here, but I'm going to draw an open circle because my x value can't actually be equal to 2. It's just between 0 and 2, but not actually equal to 0 and 2. So that's going to be an open circle. That I get from my less than symbols here. It's just less than, not less than or equal to. The last one is the absolute value of x, anywhere that x is greater than or equal to 2. So I'm going to start at 2. I'm going to start by plugging in values, but I'm going to start by plugging in x values of 2, because for this particular function, my x values can only be greater than or equal to 2. So if I start at 2, I plug in 2 into the absolute value of x. So the absolute value of 2 is 2. So 2, 2, start there. Then I plug in, I'm going to keep going because it's anything greater than 2. So if I plug in 3, the absolute value of 3 is 3. Plug in 4, the absolute value of 4 is 4. And 5. And since this one goes on to infinity, we can draw an arrow. So here are the 3 different pieces of my piecewise function. Each one only spans over the specified domain that's given to you in the very beginning. So now that we have our graph, let's try and figure out what the range of this function would be. So what would be the y values? So if you look at the lowest y value that you have on your graph, that's at 0. Okay? And on both sides, it continues on to infinity. So we can say that our range goes from 0 to infinity. Oops, did it again. So range is all of our y values from 0 to infinity. Okay, so So that is a lot of information that we're getting just from that one particular graph. So let's go ahead and do one more together. So here's our next piecewise function. 3 different pieces again. So 3 different functions that we're piecing together to represent one function. So let's talk about the domain. So let's first look at the first function and its restriction. So this one goes from -3 to 1. So x can be greater than or equal to -3 and less than 1. So just between -3 and 1. The next one goes from 1 to 4. But again, it's just greater than 1, not greater than or equal to 1, and less than or equal to 4. And lastly, we have anything that's greater than 4. So from 4 to infinity. So you'll notice here in the top one, it goes from -3 to 1, but is not equal to 1. And then the second one goes from 1 to 4, but is still not equal to 1. So in this particular function, it sort of skips over 1, because in neither of those domains are the x values ever equal to 1. So what we would say for that domain is that the x values go from -3 to 1, union from 1 to infinity. Okay, because it goes from 1 to 4, it can be equal to 4, and then 4 to infinity. So that kind of meshes together. But we skip over that 1 because in neither of those domains is it ever equal to 1. All right, let's look at the y-intercepts and the x-intercepts. So again, for the y-intercepts, we're plugging in 0 into our x value. So we need to figure out where in our domain is there an x value of 0. Which one of those 3 individual domains can we do 0? So from -3 to 1, 0 is in that span. 0 is greater than -3 and it's less than 1. So we're going to use that top function again to figure out our y-intercept. So plug in 0 for x. You get y equals -2. So 0, -2 is going to be our y-intercept. Our x-intercept, or intercepts, you can have more than one. We're going to plug in 0 for y. So we're plugging that into the f of x. So for all 3 of those different functions, we're going to plug in 0 for y. So 0 equals -x minus 2. 0 equals the square root of x, or 0 equals x minus 4. So we get x equals -2 for this one. We get x equals 0 for this one. And x equals 4. This one. So our 3 intercepts are going to be -2, 0, 0, 0, and 4, 0. All right, let's go ahead and find the following. F of -2. So again, -2 is our x input. So we need to figure out which domain has -2 in it. So from the first domain is from -3 to 1. Well, that works because -2 is greater than -3 and is less than 1. So that fits into the first domain. So we use our first function. So we're plugging in -2 for x, and we get 0. F of 4, so we need to figure out where in the domain does that fit. Well, that's going to fit into our second function because that domain is from 1 to 4, and it can be equal to 4. So our 4 fits into the second function, So plug in 4 for x, and we get 2. Lastly, f of 6, that number is greater than 4. So we're going to use our last function because the last function is used for any x values that are greater than 4, which would be 6. 6 would be greater than 4. So we're going to use x minus 4 to evaluate that one. So we get 2. All right, let's go ahead and graph this function. So we'll start with the first function, negative x minus 2. So that domain ranges between negative 3 and 1. So I'm going to start at negative 3 on my x values, plug in negative 3 for x into this function. So negative 3 goes in for x. So negative of negative 3 is positive 3, minus 2 is 1. So negative 3, 1. And since it's can be equal to negative 3, we're going to use a closed dot. Then I'm just going to keep going all the way through that domain. So the next value would be negative 2, because it goes from negative 3 to 1. So I'm going to keep going to the right. So if I plug in negative 2, I get 0. If I plug in negative 1, I get negative 1. Plug in 0 and get negative 2. Plug in 1 and get negative 3. So that is the negative x minus 2 graph only between negative 3 and 1. I'm not going to draw in any arrows because it doesn't go to infinity. The domain only goes from negative 3 to 1. Our next graph is the square root of x between 1 and 4. So I'm going to start at 1. However, you notice this x can be greater than 1 but not equal to. So when I start at 1, I'm going to use an open circle. So plug in 1 into my function. The square root of 1 is 1. And I'm going to use an open circle. So you always start at that first number in your domain, but you have to determine if that's going to be an open circle or a closed circle. Okay. So my next value that I could plug in is 2. And when you take the square root of 2, you get about 1.4. So 2 and about 1.4. Square root of 3 is about 1.7. And then the square root of 4 is 2. Okay. So it's going to be that square root curved type graph only between 1 and 4. And since it can be, we have x is less than or equal to 4, I can do a closed dot for that one. All right, last function is our x minus 4 for any x value greater than 4, but not equal to 4. So we start with 4, because that's for our first x value, because x can be anything from 4 and above. So if I plug in 4 into my last function, I get 4 minus 4, which is 0. I use an open circle because it's not equal to. My next one on the graph is 5, so I plug in 5. 5 minus 4 is 1. Let's go ahead and do one more. Plug in 6, so I get 2. And this one does continue on to infinity, so we can draw an arrow at the end. So it's really important that you pay attention to that open circle and closed circle, because remember, this is a function, and a function has to pass the vertical line test. So since right here we have an open circle, because it's not actually equal to 1, and a closed circle, it still passes the vertical line test, because I only have one point where it's equal to 1. Same here. This will still pass the vertical line test because one circle is open and one is closed. So there's only one point where it's actually equal to 4. If both of them were closed circles, that would no longer be a function. So you have to pay attention to that open circle and closed circle. All right, let's go ahead and really quick figure out what the range is for this. So our y values. The lowest y value on this graph is -3. So it starts at -3, keeps going up, and since the graph on the right continues on to infinity, we'll say that the y values also continue on to infinity. Okay, so what I want you guys to do right now is we have 2 more piecewise functions. I want you to do these 2 on your own and be prepared to share and discuss when you come to class. So when you come to class next, these should both be done, and I will call on some people to share out after you have discussed it with your groups for a couple of minutes.